students, this is my first video based on fugacity, which is one of the important concepts of chemical engineering thermodynamics. Subsequently, my other videos on the different concepts of chemical engineering thermodynamics will be uploaded soon. So today we would talk about the fugacity. So what is the exact meaning of fugacity? So meaning of fugacity is escape. So fugacity, this word is usually we used for the to define the or to explain the behavior of real gases, and it defines the escaping tendency of real gases in the heterogeneous system or in mixture. Now, what is the meaning of escaping tendency? So escaping tendency is change of phase. Now, as we all know, we have two different types of phases. One is the homogeneous phase and second one is heterogeneous phase. Homogeneous means it has only one phase, solid, liquid and vapor, and heterogeneous phases are the combination of two different phases, and we have number of heterogeneous phases. Like let's take the example of solid solid, solid liquid, liquid liquid, liquid vapor, vapor solid, and so on. So fugacity explains or defines the escaping tendency of real gases in the heterogeneous system. When the escaping tendency is same for the two phases, then we can say that system or both the phases are in the equilibrium. Now, what is let's take the example of escaping tendency or fugacity. We used LPG gas, which is liquefied petroleum gas, for our household purposes. So as we all know, LPG, with the full form of LPG is liquefied petroleum gas. So initially we have gas, and then we compress this gas and we convert it into the liquid for the storage purpose, and we use that LPG in terms of in which phase, in the gas phase. So what happens over there, what we do over there, we have initially the gas phase, and then we apply the pressure. The pressure is very high, and at a certain pressure or at a specific pressure, that gas has changed its phase and it is converted into liquid, and then we store it. And when we actually require, so what we do, we just remove the wall, then the pressure is released and that liquid is converted into the gas. So that particular pressure at which the gas has changed its phase from solid gas to liquid or liquid to gas is known as fugacity. So there are so many other examples are also there, let's take the example of deodorant. So deodorant also we stored in the liquid phase, and when we press the knob of deodorant bottle, so it comes out as a gas. So again, that pressure is there, that pressure is known as fugacity, and so many examples are there. These are the examples of real life. Now fugacity is defined by the alphabet F. For an ideal gas, fugacity is directly proportional to the pressure. So F upon P is equal to C, and C is what? It's a proportionality constant, and for an ideal gas, this proportionality constant is equal to the 1 or unit. So F is equals to P. So for an ideal gas, fugacity is equal to the pressure. And now we know that what is an ideal gas. So when we have the gas, any kind of real gas, so we have the gas and we reduce the pressure of that particular gas, then the pressure approaches to 0, then that gas is known as an ideal gas. For a real gas, the fugacity is not directly proportional to the pressure. So here the ratio of fugacity to pressure is not equal to 1. So we need to find out this, and then we can find out the fugacity. Now, this is basically it. This is the concept of fugacity. There is one more term which we used often in chemical engineering thermodynamics, which is also related to the fugacity, that is known as fugacity coefficient. So fugacity coefficient is nothing, it's just a ratio of fugacity to pressure, and it is known as fugacity coefficient, and which is denoted by phi. So fugacity coefficient is ratio of F upon P, and it is equal to phi, and it is known as fugacity coefficient. Now this is a dimensionless, this is a fugacity coefficient is dimensionless. Why? Because fugacity has the same, fugacity has same dimension like pressure, so that phi is dimensionless. And it is the fugacity coefficient depends upon the nature of gas, temperature and pressure. For an ideal gas, the fugacity coefficient is 1, and for real gases, fugacity coefficient is not equal to 1. So we need to find out the fugacity coefficient for the real gases. And now the next question which arises over here, ki how to find out the fugacity coefficient or fugacity for the real gases. So for that we need to collect the data from the experiments, and then with the help of these data we can calculate the fugacity and fugacity coefficients, which actually defines or explains the behavior of real gases. So that is all about the fugacity and fugacity coefficient. Hope you understand the concept of fugacity. That's it for today. Thank you.